Hi Rock Buds, it's Rock Papa. Hope you guys are doing fantastic today. Today I'm going to tell the story of the geologic history of Durango, Colorado. It will also be the geologic history of the Colorado Plateau, which basically encompasses Utah, Colorado, Arizona, and New Mexico. We'll start with the Precambrian period about 2 billion years ago and come on forward to about the Pleistocene period, which was about 2 million years ago. And along the way, we're going to learn some interesting things like where did the Colorado Plateau come from, and also why are the highest peaks of the Rockies rocks that are billions of years old, even though the present-day Rockies were pushed up fairly recently in time. We'll learn things like where did the Painted Desert and the Petrified Forest come from. We'll learn about the greatest sand dune desert the world has ever known, and also where all the dinosaur bones came from that we find in our museums around the world. So stay tuned, and if you like this video, please subscribe. Thank you so much to everyone who has subscribed. Helps me immensely. So here we go, the geologic history of Durango, Colorado, and the Colorado Plateau. Around 2.5 billion years ago, a small supercontinent called Columbia began to come together. One of the last acts in the assembly of supercontinent Columbia was when the Colorado Plateau Island Arc crashed into the mainland. In the last video, I called this the Grand Canyon Island Arc. Either one. The main point is that it contained most of the present-day Colorado Plateau parts. Granite gneiss was produced in this island arc development and crash. Also some ancient felsic tuff blown out of these stratovolcanoes. And there were basalt lava eruptions as well. All ancient rocks today. And here's some ancient quartzite. You know, as the ancient island arc crashed and then began to erode into its foreland basin, one of the last sediments is a clean layer of beach sand. And that's where I think this quartzite came from. Columbia supercontinent rifted apart between 1.5 billion and 1.35 billion. This produced granite that was intruded into the existing granite gneiss, also diabase, which acts as the blowtorch that rips a supercontinent apart. Hey guys, all these rocks that we've just been discussing can be found around Durango, Colorado, and other places in the Colorado Plateau, and they're very ancient. Then came the next supercontinent, Rodinia, which we are all familiar with. It came together about 1.2 billion years ago and immediately began rifting apart between 750 and 550 million years ago. As Rodinia rifted apart, the continent pieces began to sink, and the rift-to-drift sequence of sediments was deposited. And you can find these sediments in and around Durango along the Animas River. You may remember that the rift-to-drift sequence of sediments happens when the continent edge sinks, the sea rises. The first layer that's deposited is a layer of beach sand, then comes a layer of mud, and finally a layer of limey mud, which turns into limestone, and in that limestone is where the Cambrian explosion of life happened. The Sahuache sandstone represents the Cambrian sand beach layer. Parting sandstone was happened in Devonian and may be related to the Acadian orogeny. And then the Leadville, which is limestone, was a Mississippian limestone. You can find these around Durango and in other places on the Colorado Plateau. And here's some limestone that we came across in the parking lot to the Cascade Creek Trail north of Durango. The white streaks are more than likely calcite veins. We have now come to Pennsylvanian and Permian time, which lasted from about 330 million years ago to about 250 million years ago. Pangaea's supercontinent was coming together, and that involved the huge Alleghanian orogeny in the east when Africa crashed into the mainland, and also the ancestral Rocky Mountains in the Colorado Plateau were pushed up. Here is Colorado during the ancestral Rocky Mountain time. The blue arrow points about to where Durango, Colorado is. There were two major uplifts associated with the ancestral Rocky Mountains, and in between those uplifts were shallow seas. The uplift on the right is called Front Rangia, not to be confused with today's Front Range. And the one on the left is called the Uncompahgre Uplift, which is a crazy name that I can't spell, so I'm going to call it the Uncle Padre Uplift. Hope geologists don't get mad at me. Over many millions of years, these ancestral Rocky Mountain uplifts eroded huge amounts of sediments into all of the surrounding basins, producing thousands of feet of sediments that you can see around Durango, Colorado, and other places in the Colorado Plateau. As you drive through Colorado, you're going to see huge cliffs of reddish sandstone and siltstone. For example, the Maroon Bells Formation near Aspen, Colorado. The Colorado Red Rocks Amphitheater just west of Denver. And the Garden of the Gods Park in beautiful Colorado Springs. All of these were the red sediments eroded off the ancestral Rocky Mountains. Next came the Triassic period, which lasted from about 250 million years ago to about 200 million years ago. Supercontinent Pangaea was in effect. The huge Allegheny orogeny mountains and the ancestral Rocky Mountains had eroded substantially down to the sea. Most of the United States was a relatively flat, hot, dry coastal plain. Iron-rich red sediments were accumulating around Durango and the Colorado Plateau. And in this picture, you can see the Sonoma orogeny foreland basin in the upper left of the picture. Mud of the Moenkopi Formation drifted down and began to fill up this Sonoma foreland basin. Then came the red coastal plain sediments of the Chinle Formation, and at this time there was tremendous volcanic activity associated with the Nevada orogeny on the west coast, which dumped millions and billions of tons of volcanic ash onto the ancient Chinle forest, giving rise to the petrified forest and the multicolored strata of the Painted Desert. Next came the mighty Jurassic period that lasted from about 200 million years ago to about 150 million years ago. During the Jurassic period, Pangaea's supercontinent was beginning to break apart, and this was the time of dinosaurs and huge deserts. Hey rock buds, one of the reasons for these massive deserts and sand dunes was the fact that North America had moved up into the westerly wind belt where the winds blew from the west. That's opposite of the way they had been blowing for millions upon millions of years, so that all these coastal plain sediments that had been drained down during the Triassic period were blown by the west winds into huge sand dunes. Here's the area around Durango, Colorado, showing the sand dunes that developed during the Jurassic period. The yellow circle circles the wind direction coming from the west, which blew up all these eroded sediments into huge sand dune deserts. If you go to places like Colorado National Monument in western Colorado or Capitol Reef National Park in Utah, you get to see some of these magnificent layers of sandstone that were once the world's greatest sand desert. Here's the Entrada sandstone, which you can find around Durango, Colorado, and at Arches National Park in Utah. The last great deposit of Jurassic time was the Morrison Formation, and it was once again a massive coastal plain, but this time the coastal plain drained from the west, where these huge orogenies were occurring, creating mountains that eroded from west to east. The massive volcanoes of the Nevada orogeny in the west dumped tons and tons of volcanic ash onto the Morrison Formation, giving it that multicolored appearance similar to the petrified forests of the Chinle. This is Dinosaur National Monument in northwestern Colorado. It's a showcase for the many kinds of dinosaurs that roam the Jurassic Morrison Formation and inspired Jurassic Park. By Cretaceous time, which lasted from about 150 million to about 65 million years ago, North America was in the westerlies belt, and the climate was much more moist than before, so no more red sediment. The severe orogeny was in full swing, and its huge mountains pushed down on the western edge of the continent, creating a massive foreland basin that's called the Great Cretaceous Sea. This massive but shallow ancient sea was filled with sediments that became the Mancos Shale, also called the Pierre Shale. Then came a layer of sandstones that we call the Mesa Verde Formation. About 40 miles west of Durango, Colorado, we find the Mesa Verde National Park, which highlights the ancient Indian ruins that were developed in the Mesa Verde Formation. Then around 70 million years ago, the Laramide orogeny began, and it was completely different from every orogeny that came before it. In the upper picture of this picture pair, you see the west coast of the United States with the Farallon ocean plate subducting underneath the edge of the continent, and the subduction angle is 45 degrees. That is what usually happens, and so the mountains that the subducting ocean crust creates are fairly close to the coast, say within 100 or 200 miles. On the other hand, the lower picture shows that the subducting plate has gone kind of flat and pushed way up under the continent, and that is what created our Rocky Mountains so far inland from the west coast. Hi guys, not all geologists agree with this flat plate subduction idea. There are some geologists now that have a new theory that they call the hit and run theory. I don't know the details of it, but it might be interesting to look it up. But the bottom line is the huge mountains produced by the Laramide orogeny were far inland from the west coast and are our present day Rocky Mountains. The Laramide orogeny produced massive stratovolcanoes all over the Colorado Plateau, including in the Durango area. It also produced granitic intrusions called laccoliths, which occur when granitic magma is pushed up into existing sedimentary layers and gets this mushroom kind of shape to it. Here's some of the Laramide orogeny volcanic deposits produced around Durango, Colorado. The volcanoes of the Laramide orogeny also pumped all kinds of valuable metals into the rocks, including gold, silver, copper, zinc, lead, sulfur, and iron. These gave rise to Colorado's tremendous mining industry and also gave rise to high metal content in a lot of Colorado streams that they're still trying to clean up. Don't drink this water. And now we come to the final act that created the Rocky Mountains that we know today. Remember the flat plate subduction business that created all the volcanoes? Well, around 70 million years ago, the plate dropped back down, and that took the pressure off of the crust, and the crust began to expand and flatten out and stretch and crack into many places, creating faults. All these faults that were cracking up the Colorado Plateau caused ancient Precambrian rocks that were buried deep in the ground to be thrust up, creating the Rocky Mountains that we know today. Geologists call these upthrust basement chord uplifts. This is a picture of the Grand Tetons National Park, with the peaks that are upthrust are billions of years old. But the upthrusting was fairly recent in geologic time, creating some of the youngest of the Rocky Mountains. Here are some more basement chord uplifts, also called the Rocky Mountains, for your viewing enjoyment. All this block faulting that occurred when the Laramide plate fell away opened up the bowels of the earth, and basalt lava flows came out, covering thousands of square miles. Here is Grand Mesa, a huge basalt lava flow in west central Colorado. Okay, rock buds, there you have it. Thank you so much for watching this very long and detailed video. I hope it's been useful for you. Watch it as many times as you'd like, and hope you guys will have a great 4th of July coming up. And this is your Rock Papa saying, happy rock hunting. Papa out.